Alrighty, so today we are going to be working on systems of equations notes, systems of equations. And it's basically everything you already know, but double the trouble. Also today I am back at the school building for the first time since the pandemic, so I'm very excited to be back and also sad because there's no kids in here, but we'll get through it. So anyways, we're gonna start by defining what systems of equations is. Okay, so I'm just going to write the word definition. Okay, and essentially systems of equations, you remember when we did functions, everyone? Remember we did functions a long time ago? It's just that, but it's when you have two functions going on at the same time. All right, so the way that we're going to write our definition, we're going to say two or more, it could be more too sometimes because it gets crazy, two or more equations in the same variable. So both of the equations have to have the same variables, all right? They can't have different variables. So there we go. All right. Now, the solution to a system. So when I tell you to solve a system, what am I talking about? Are you solving an equation? Are you what's going on? So the solution to a system, there's two ways to find it. One, you can find it by graphing, so graphically. Okay. So one, you can find it graphically. And when you graph, basically if I graph two lines, it's the point, right, written like an ordered pair, the point x, y, where the two lines intersect. And intersect means crossing. So when I have two lines, wherever they touch and intersect, that is my solution. That point is my solution. It's going to look like a point like this, okay? The other way, for example, let's say I don't have a graph. The other way I can solve it is using algebra. I can solve it algebraically, okay? And that is going to be the point, and I'm going to find an x value and a y value, but I'm going to do it by doing algebra instead of graphing, right? An x and a y value that makes both equations true. And we'll talk about what that means in a second. Okay? So when we're doing systems, there's three types of solutions that we can have. So I want you to write the words types of solutions. Because right now it's possible that none of this makes any kind of sense. All right, so types of solutions. Okay? Now what I want you guys to do is draw a line all the way across. All right, draw another line all the way across. Gonna give yourself some space. And then draw maybe a smaller line like this. Okay? And then we are going to break this up into three even sections, maybe something like that. That's about as even as I can get. Okay? All right, so again, three types of solutions. The first type is called intersecting lines. Remember we said intersecting is when they touch each other. So that's when you have one system, right? One line, oop, that's not straight. You have one line going this way, and then you have another line going this way, and the point where they touch is your solution. intersecting lines. A point where they touch is your solution. The second kind of solution you can have is called parallel lines. Okay? And parallel lines is when you have one line and then you have another line that looks almost exactly the same, right? And remember, parallel lines, they will never, ever, ever, ever touch each other. They will never, ever, ever, ever touch each other. So I can't even like point to a solution here for you, okay? And the third type of solution, the third type of solution is called same lines, okay? And that's when you have one line, but the other line is directly on top of it, like that. So basically, they're like always touching. They're always touching. So when we see these kinds of systems, the first type, the intersecting lines, together, this only has one place where they touch. So this only has one solution. And when there is only one solution, we are going to find the exact point on a graph and write that down. Okay? When it's parallel lines, these lines never touch. So there is no solution here. They are never going to touch each other. And the symbol that we use for no solution, it's kind of like this 0 with a line that goes across. So this is what you would write if you have parallel lines. And then finally, if you have the same lines, they're always touching forever and ever and ever. They are always going to touch. So this has infinite solutions. Infinite solutions. And we use the infinity sign to talk about infinite solutions. In the next video, we're going to talk about how we graph or solve for these kinds of equations. So now that we have this part of our notes, we are going to do one example of graphically finding the solution and one example of algebraically finding the solution, okay? So I'm going to scroll down. I want you guys to go down to the next part of your notes, and I want you to create this 8 by 8 graph, okay? It goes 8 in each direction, all right? And this section is going to be called by graphing. We're going to find the solution of our system by graphing. Okay? And here's our system right here. I want you guys to copy that down as well. Now, for those of you who forgot how to graph, okay, I'm going to put down the steps again. So first, you want to, well, let me write this down actually. All equations that are linear can be written as y equals mx plus b, okay? So the first thing you want to do when you graph is you want to plot the b on the y-axis because the b is our y-intercept. So for my red equation, my b is -6. So I'm going to find -6 on my y-axis. And -6 is 1, 2, 3, 4, 5, 6, right here. Okay? That's for my red line. The second thing I want to do is I want to find the rise and run from the M to move to the next point. okay? So again, for my red equation, the m is 2. Okay, so I'm just going to write that down really quickly. M equals 2. All right, and we know that all of our equations for the slope m is rise over run. So I automatically know that my rise is going to be 2. However, what's my run? And if we remember for fractions, all whole numbers have a denominator of 1 automatically. So to move to my next point, I'm going to rise, which is moving up 2, and run, which is left 1. So starting from my starting point, I'm moving up 2 and over 1. This is my next point. Okay? And I'm going to keep doing that. Up 2, over 1. Up 2, over 1, until I don't have any more space. Okay? And I'm just going to erase these lines that I drew. So that is my red equation, and I'm also definitely going to connect all the lines. Just like that. Okay, now let's plot my blue equation. So again, my first step is what? To plot the b, which is positive 2, on the y-axis. So my b is positive 2 on the y-axis is right here. Okay, it's right there. Next, again, I need to find my rise and my run. So here, we have negative 2 over 3. So I'm going to do negative 2 over 3, which is my rise and run. And this is already in fraction form for me. So my rise, because it's negative, I'm not going to go up, I'm going to go down this time. And my run is always going to move to the right. Okay? So starting at my blue point, I'm going to rise down 2 and over 1, 2, 3. Down 2, over 3, and that's about as far as I can go. Okay? And when I connect my dots here, this is the line that I kind of get. Okay? So what's my solution then? What is the solution here? So my solution is where the two lines cross, which is right here. Okay? That is my solution. So I'm going to write solution and this point is on the x-axis is at 3, and on the y-axis is at 0. So my solution is 3, 0. Okay? And that's it. All right, the next thing we're going to do is work on solving systems by algebra. All right, so now we're going to do a method to solve systems called substitution. So I'm actually going to go down to my next page because I am out of space, and I'm just going to draw a straight line to kind of organize my notes. All right, this guy said I don't feel like being, there we go. All right, so now we're going to do the substitution method. So by substitution. Okay, and to start off, why don't we write down our steps so that we can do all our work at the bottom. Okay, our first step is to isolate a variable in one equation if needed. Sometimes we can skip this step. So we want to isolate a variable in one equation if needed. Okay? And then we can say substitute the value of your first variable into the other equation. Sounds crazy, but when we do the math, it might be easier. Okay, substitute the value of your first variable into the other equation. Then substitute the value, substitute the value of your first variable into an equation, or into the original equation to find the value of your second variable. Okay? And then finally, write your solution as an ordered pair. Okay, lots of crazy stuff going on here. Let's see what the heck is Mr. Rec talking about. All right, so let's do examples. So I'm going to write example right here. Let's do an example. Okay, the first example that I have for you is the system 3x plus y equals 26 and y equals 18 minus x. That's the first system we're going to work with. Okay? Now let's look at our first step. Our first step says to isolate a variable in one equation if needed. When I'm looking at my equations, I notice that y is already all by itself on one side of the equation, which means that y is already isolated. So I do not need to do anything here right now. I don't need to do anything, okay? I can skip that first step. So my second step is I need to substitute the value of y. So y is equal to 18 minus x. And I need to take that 18 minus x and replace it wherever I see a y in the first equation, which is right there. So let me show you what I mean. I'm going to rewrite that first equation as 3x plus, but instead of writing y, I'm going to replace that with 18 minus x, right? Because 18 minus x is equal to y. They're the same thing. They're replaceable. So I'm replacing it and writing the rest of the equation equals 26. Okay? So what this does is it makes my equation all with one variable instead of x and y, which makes it easier for me to solve. So let's see what's going on here. I'm just going to rewrite this again. 3x plus 18 minus x equals 26 because I don't need those parentheses there. Now I think I want to combine like terms. So 3x minus an x is 2x plus 18 equals 26. Okay,
I want to isolate my x, so I'm going to subtract 18 from both sides, which leaves me with 2x equals 8. And then I'm going to divide by 2 on both sides, which leaves me with x equals 4. So I have my x value, okay? However, I'm not done. Remember that a system of equations, right, it's where two lines meet at a point. So I have the value of my x coordinate, but I need to find the value of my y coordinate, and this is what I do. Now that I have x equals 4, I'm going to plug that in to the second equation, which is right here. So I'm going to rewrite this second equation now, which is y equals 18 minus x, but I'm going to replace the x with 4 because I found the value, 18 minus 4. And we know 18 minus 4, that was so annoying, I'm sorry about that, that was the bell for class. We know that 18 minus 4 is 14, which means y is 14. We're not done though. To write our solution, I can write it at the top. The solution is 4, 14. That's how you want to write it, as an ordered pair. Okay? So what I'm going to do is I'm going to give you guys another example to do on your own, and then let's see if you guys can get the right answer. So this one will be, let's see which one we want to give you guys. 2x plus y equals 11, and y equals x minus 2. Try solving that one and see what answer you come up with. The solution that you should have gotten for your second practice problem is 3, 5. And if you guys need help going over it, the first thing that I was going to do is take the value of y, which is here, and substitute it in where I saw y. So I would have rewritten my equation as 2x plus x plus 2 here equals 11. Okay? Then I'm going to combine like terms, which gives me 3x plus 2 equals 11. Okay? To isolate x, I'm going to get rid of my 2 on both sides, which leaves me with 3x equals 9. And then the last step is to divide by 3, which leaves me with x equals 3 as my x coordinate. Now we know that that's not enough. My x coordinate is not enough to know my solution. I need to also find my y value. So I'm going to take this x value that I found and substitute it into the other equation that I did not use yet. Okay, so I'm going to replace the x here. So x is 3, so we have 3 plus 2, which is 5, and my y value is 5. And you have to remember to write your solution as a coordinate, as an ordered pair. Now you guys are going to be so mad because you're doing all this work, but there is a much easier way of solving these equations. And the last way I'm going to show you is called by elimination. By elimination. Okay? So when you're eliminating, all right, you probably will see an equation that looks like this. 2x plus 3y equals 15, and x minus 3y equals 3. Let's say we're working with this equation. All right. Now you notice that positive 3y and negative 3y are opposites, right? plus positive 3y minus 3y is 0. So whenever you see pairs like this that can cancel each other out, we're going to use the elimination method. And the way it works is we are just going to add or subtract whatever we see. We're basically going to combine like terms vertically, like this. And this is what I mean by that. Okay, I'm going to draw a line right here. 2x plus x is 3x if I combine like terms. Okay? 3y minus 3y is 0. Bring down my equal sign. 15 plus 3 is 18 if I combine like terms. Okay? It's called elimination because this whole piece got eliminated. All right? So now I have 3x plus 0, which is just 3x, equals 18. To solve that, all I have to do is divide both sides by 3, which gives me x equals 6. Just like that. You literally just combine all your like terms, which eliminates one of your terms, and then you just solve your equation. Done. However, don't forget, that's not enough. We still need our y value. So I'm going to take the x equals 6, and I'm going to plug it into any other equation that I want. And I'm going to plug it into the second one. Okay? So I'm going to take this x and sub it in. So if x is 6 minus 3y equals 3, okay? I'm going to take away the 6 from both sides, which leaves me with negative 3y equals negative 3. I'm going to divide by negative 3, which leaves me with y equals 1. So my solution here is 6, 1. Okay? You know that's not enough though. You know I'm always going to make you guys do an example problem. So if this was example 1, I want you guys to do example number 2. And that one will be 2x plus 3y equals 20. Negative 2x plus y equals 4. See if you can solve this one. Remember, you're just combining like terms vertically. Okay? Pause the video and try it, and I'll give you the answer in a second. Okay. Oh, there is our announcement. Give me a second. All right, there we go. Okay, so if I was doing this, when I combine my like terms, we have 2x minus 2x, which cancels out. 3y plus y is 4y. 20 plus 4 is 24. So really, my equation is 4y equals 24. If I divide both sides by 4, I get y equals 6. Okay, I have my y value, now I need my x value. So I'm going to take the second equation. I don't know why I like these second equations, but I do, which looks like this. And I'm going to sub the y with 6. So I'm going to rewrite this as negative 2x plus 6 equals 4. I'm going to subtract 6 from both sides, which gives me negative 2x equals negative 2. Divide by negative 2 on both sides, which gives me x equals 1. So my solution should have been 1, 6, which is literally the backwards of what we just did. Okay? That is it. That is all your notes for today. Good job, guys. So we did 3 things. We did finding systems by graphing, finding systems by substitution, finding systems by elimination.